topic is linearization, and let's consider the following nonlinear equations. Z is equal to xy plus 10x squared y, and x0 is equal to 1, y0 is equal to 2. All right, linearization problems have a standard form. In this problem, we can see we have two variables, so here's what our standard form is going to look like. It's going to be g of x comma y approximately equal to, it's going to be g star of x0, y0, which is just us evaluating the z function at the initial conditions, plus partial derivative of z with respect to x at x0 and y0. Then we're going to multiply all of that by x minus x0. And then we're going to add another partial derivative of z, this time with respect to y, evaluated at x0, y0. And then we're going to multiply that by y minus y0. So here's our standard form for linearization using Taylor's series and ignoring higher ordered terms. So as you can see, we've got 1, 2, 3 things to take care of. Let's get after the first one. G star of x0, y0 is equal to xy, and again they're 1 and 2, so it's going to be 1 times 2 plus 10 times 1 squared times 2. All right, here we go. 1 times 2 is 2. 10 times 1 squared times 2 is going to be 20. So g star of x0, y0 is going to be equal to 22. Good. Moving on to number 2. Partial derivative of z with respect to x. All right. That was 1. This is 2. That's going to be, with respect to x, is going to leave y as the constant, plus 2's coming out, dropping the power of x down to 1. That's going to be 20xy. And now we're going to evaluate at x0 equal to 1, y0 equal to 2. Okay, so 2 plus 20 times 1 times 2 is equal to 2 plus 40 is equal to 42. We're not done yet. Now we multiply by x minus x0, which leaves us at 42x minus 42 times 1, which leaves us with 42x minus 42. Component number 2. All set. Moving on to number 3. Here we go. Partial derivative of z, this time with respect to y, is going to give us x plus 10x squared. And we're going to evaluate at x0 equal to 1, y0 equal to 2. So here we go. X is 1 plus 10 times 1 squared is going to be equal to 1 plus 10 is equal to 11. Not done yet. Now we multiply by y minus y0, which is equal to 11y minus 11y0. y0 is 2. So we've got 11y minus 22. Component number 3. All squared away. All right, switch to different color. We're going to bring it all together now. We're looking for the linearization of the z function in the form of g of x and y. So it's g of x and y is equal to our first term, 22, plus our second term, 42x minus 42, plus our third term, 11y minus 22. All right, 22 there, 22 there, you guys are gone, and we're left with negative 42. Here we go, we've got g of x comma y equal to x term, 42x, y term plus 11y, constant term minus 42. Final answer.